Okay, so this is going to be chapter 25, radicals and exponents. So let's, well, first of all, if you have this already, make sure to attempt the problems on your own and corrections on your own first before referencing this video for explanations on where you're stuck for the best results. So let's start with number 1. So it says solve for x in the following equation. So remember, when you have a fraction as an exponent, the top number tells you what you're raising the base to, the x2 basically, and the bottom number tells you what kind of radical you have, so you have a square root. And that needs to equal 27. So basically, what number cubed and then square rooted equals 27? Well, I know 9 times 3 equals 27, so whatever I'm taking the root of in here, I have to get a 9 out of and a 3 out of. So let's think 9 squared is just 9 times 9. And then if we had times 9 again, we could take out a 3 for this, and then we could take out one of the 9s for that. 9 times 3 is 27, so it would be B. Now let's go to number 2. If 382 is 194 less than 4 times the square of x, then what is the value of x? So 382 equals is, and then we're going to have 4 times the square of x, and it's 194 less than that. And then we just need to solve for x. So let's add 194 to each side. So then that's going to be 576, yeah. Equals 4x squared. Then if we divide by 4, that's going to be 144. And then we have that equaling x squared. So then now it's going to be, if we square root each side, we could say that x could either be positive or negative 12. Like, both of those would work. If you do negative 12 squared, you get positive 144. If you do positive 12 squared, you also get positive 124. So it's 1 and 2. So the answer would be D. Okay, so now let's go to, I almost skipped number 3. Number 3 over here. What is the solution to the following equation? So let's try and get x by itself. So most people would probably be best off actually moving this over so they don't have to deal with the whole negative situation. So I'm going to do that first, but you can go about it differently if you want. So then that's going to be, that's going to leave you with 2 over here is equal to negative 5 plus root x. Then you're going to add 5 to each side to isolate root x. So then you're going to get 7 is equal to the square root of x. So you have to ask yourself, okay, well, what would go inside the square root? That would give you a 7. And that would be 49, because the square root of 49 is 7. So let's now go to this one right here. Which of the following is equal to the cube root of negative 375? So cube root of negative 375. Hold on, there's a little hair there. There we go. So there's 4 groups of 25 and 100. So then times that by 3, you get 12, and then 3 to get to, so then that's 15. Okay, so it's going to be the same thing as negative 25 times, the negative of 25 times 15 cubed. Hold on. You could probably break that up further, yeah. So then you could break this up into 5, 5. This is broken up into 5 times 3. So then you have 3 groups of 5 that you can, there's 3 versions of 5, basically. So you could take out one of them on the outside. And then you're left with the cube root of 3 on the inside. Now remember, there's that negative value as well, so you have to keep that. And it's just going to be, wait, hold on. That doesn't have a negative in front of it. This one has a negative in front of it. D. So then let's go to number 5. Which of the following is equivalent to the square root of 50? So let's think of ways that we could rewrite the square root of 50. Remember, when you're simplifying with radicals, you are going to think, okay, I need to break this up into factors. So like, what factors can I break this up into? And like, you could look also at the answer choices to kind of like help you. Like I see there's 25 is showing up a bit. So maybe I'll start by breaking it up into 25 and 2 as the factors, because 25 times 2 gives me 50. So then that would be the square root of 25 times 2, which is the same thing as saying the square root of 25 times the square root of 2. So number 2 works. And then, but we can say just from that number 3 would not work, because this would have to be a 4 for us to take out a 2 and leave a 25 on the inside, which we don't have. So that's wrong. And then let's see if there's a way to get 5 root 2. Well, this 25 can be broken up into 5 and 5, because 5 times 5 is 25. So here's a pair of 5s. So we could take out a 5 and leave a root 2 on the inside, which is what number 1 says. So it would be 1 and 2 only. So C. And let's go to number 6. For number 6, we want to know the solution. So let's get x by itself by adding 7 to each side first. So then that's going to be x squared is equal to 25. So we would say, okay, what number squared gives us 25? Well, that could be -5. It could also be +5. So that's going to be C. Okay. Now, for number 7, we have the square root of 36, and that's just equal to 6. A lot of people get confused by this one. It's kind of like not necessarily a trick question, but kind of. They think it's supposed to be B, but remember, this is different than this. This is the situation where it's the plus or minus one. This is completely different. This is just saying the regular old square root of 36, which is just 6. Okay, so let's keep on going to number 8. If y is equal to 1, then which of the following is equal to all of that, basically? So 1 to any power is just going to be 1. I mean, if you want, you could do like the whole negative exponent rule thing if you really want to, but it's just kind of useless. Because it's just going to be 1 anyways. So it's just 1 plus 1 plus 1 plus 1, which just equals +4, D. Thank you guys for the likes. And let's go to number 9. So we have this expression, and it's equivalent to this, where a is a constant and x is greater than 0. What is the value of a? So we want to find the value of a. So I'm basically going to rewrite this in this sort of format. So if I factor out the 9/18, right, I could say that this is the same thing as 9/18 times x to the 13 over x to the 4th. And then if I simplify this by dividing by 9 on top and bottom, I get that that's 1/2 times x to the 13th over x to the 4th. So now I'm going to do quotient rule with the x's and just copy over the 1/2. And I'm going to say, okay, that's 1/2 times x to the 13 minus 4, which is just 9. So you see now it looks more like this expression that we have there. And a happens to be the exponent there, which we see now is 9. So a should be 9. Okay, so is there one down here? Yeah. So now this is number 10. For number 10, we want to find the cube root of -64. So that's just going to be -4, because -4 times -4 times -4 gives us -64. So that one right there. Okay, so let's go to number 11. So for number 11, what's equal to this? So remember, if you have a fraction as the exponent, the numerator in that fraction tells you what you're raising the base 6 to, and the denominator tells you what kind of radical you have. So the 2 tells you it's a square root. So, and then it's just the same exact thing right over here. So then let's see, how can we simplify this? So 6 times 6 times 6. So then obviously this gets taken out as like a pair of 6s. So then you take out a 6 and you leave the other 6 on the inside. And then same exact thing here. And then you just need to combine your like terms, and you're going to get 12 root 6 from that. So A. So now let's go to number 12. Which of the following expressions is equivalent to this? Okay, so the whole thing inside the parentheses is being raised to the third power. You can't just do it to the x portion. That's where a lot of people go wrong with this. It's also the -3 that you have to raise to the third power. So what's -3 times -3 times -3? Well, that's going to be -27. Now you can focus on the x portion, and you could say, okay, power to a power rule says I'm going to multiply those powers, so that's going to be x to the 6th. So it should be B. Thank you guys for the likes. Please share this with anyone that needs any prep help for the SAT or ACT. Let's go to number 13. It says that we have all of this, and we want to know which of the following is equivalent to that. Okay, so we have, these can cancel out right here, so then it's just combining these like terms. So then that's just going to be 8p. Yeah, A right there. And then let me just switch. There we go. Okay, so now let's go to number 14. So for number 14, we're just using a bunch of our different, what are they called? Laws of exponents stuff to simplify this. So I'm going to start by doing the rule that says that we can raise y, like if y looks like this with the radical, we can raise y to the 18/3 instead, because it's just, if we raise it to the fraction version, it's just going to be the numerator is the number it's being raised to on the inside of the radical, and the type of radical becomes the bottom number in the exponent. And then we know that that just turns into a 6. And then also, one thing that you can do with the negatives, I mean, you could always remember, like, the negative exponent rule that you turn it into 1 over whatever it is to the positive, but an easier thing to think is just switch the positions. When you're multiplying like this, just switch the positions and make it positive. So what I mean by that is I'm going to switch the z to the -2nd, put it down here to the positive, and then this is going to be z to the 3rd, and then the same thing with the y. I'm going to make it times y to the positive version. And then now I can just do product rule, and I could say, okay, now I'm going to keep the like base, add the exponents. So then I should get A as my answer. So now let's do this one. So a lot of people, I don't know why, they think that just because there's variables involved, that this doesn't follow the rules for fractions. It's still just a fraction, like that's a fraction bar. So it follows all the same rules, even though it's just variables. So we still keep change flip when we're dividing with fractions. So you're going to keep the fraction the same on the left. You're going to change the division to multiplication, and you're going to flip this one so that it's WZ over Y. And then now you can just cross cancel. So I could say I'm going to cross cancel a W there, one of the Y's and one of the Y's here. So then I just have these all turn to 1s, and then that's just Y times Z times Z. So that's just Y times Z squared. So it would be A. So now let's go to number 16. So for number 16, let's see if there's, okay, so I'm just going to do 2 to the 20th over 2, because remember the type of radical is the denominator when you raise it to a fractional exponent. So this is a square root, that's why I'm putting a 2 on the bottom. And then I'm going to use the same logic for the y portion. And then when we simplify that, it's 2 to the 10th, y to the 2nd power. So that's just C. And I think it's up here, the next one. Someone said they're doing this in Honors Algebra 2 right now. Well, good, this will be helpful for you. So then let's go to number 17. It says, which of the following is equivalent to this expression right here? Okay, so let me see. So if you're adding the exponents, like what do we know about law of exponents that has to do with that? That's product rule, just kind of like in reverse of what you're used to. So think about it as like the precursor to getting this. like the step before this that you're used to is that it looks like y to the b times y to the second, and then you end up keeping the like base and adding the exponents. So it's kind of like doing product rule in the reverse way that you're used to. And the same thing on the bottom. So it would be y to the b times y to the third power. So then, now let's see what we can do to make it look like one of the answer choices right here. So these cancel out, and then this cancels out, and you're left with one of the y's on the bottom. So those are all canceling out to 1, and then it's just over y, so then that would just be b. And let's go to number 18. So number 18 says, which of the following is the solution to the given equation? So we're going to start by foiling this out. So whenever you have two terms plus or minus in parentheses times two terms plus or minus in parentheses, you have to FOIL, which is an acronym that stands for what you're going to multiply together. So I'm going to copy down the rest of the problem. Y squared is equal to negative, and then inside my parentheses is going to be the FOILed part. So F means I'm multiplying the first things together, y times y, which is y squared. O stands for multiply the outer, so 8 times y, so that's just going to be 8y. And then I stands for multiply the inner, so it's just going to be negative 8 times y, so negative 8y. And then L stands for multiply the last, so negative 8 times positive 8 is going to be negative 64. Now you'll see you can combine like terms to make these cancel out. Then you're just going to distribute the negative to each of the remaining terms inside of the parentheses. So then it's going to be y squared is equal to the negative of y squared plus 64. Now if I add y squared to each side, I get 2y squared is equal to 64. Now I'm going to try to get y by itself by now dividing by 2 on each side to cancel it out. And then that's going to give me 32 is equal to y squared. So now I have to square root each side to get y by itself. So I get y is equal to the square root of 32. And then I just have to simplify this. So I know that 16 times 2 can give me 32. 16 is one of our perfect squares that we memorized. So we can take out a 4, because 4 squared is 16, and leave a root 2. So then the answer would be B. Someone asked, is this algebra 2? Yeah, this would be something, this is not necessarily for like an algebra 2 textbook, but you do learn this in algebra 2. This is my book for digital SAT math, which they do test you on some algebra 2 stuff. Okay, so let's go to number 19. Some people do learn it in Algebra 1 as well. It varies by school. Like, you guys go back to a lot of the stuff and, like, review things and then add things to it. So, like, Algebra 1, Algebra 2-ish. Or some of you guys call it, like, Math 1, Math 2, and it, like, mixes it all up into, like, you guys don't even have Algebra 1 and Algebra 2 anymore. It's all weird now. And then, so let's go to number 19. Which of the following is equivalent to this expression right here? So let me see what I can do. So it's just product rule. So y to the 3 plus b over 3, because we're multiplying with like bases, so we add the exponent, so it's just going to be c. What subjects of math are on the SATs? So subjects, like if we're talking in like the regular pre-algebra, algebra 1, algebra 2, like those types of terms, it's pre-algebra, algebra 1, algebra 2, and like pre-calc. I forget if you guys are like switching out to like a different classes called trig now or not. It's like everything's all different depending on who I'm working with. So basically, yeah, everything you've learned typically up until your junior year is what they're testing you on. So that stuff, like what you're used to, like geometry also, is included on the SAT. And then, so let's go to, but there's no calculus. Basically, like, it doesn't go up to calculus is the easiest way to kind of explain it for, like, the most amount of people. So let's go to number 20. So for number 20, we have which of the following expressions is equivalent to this? So right away, I'm going to combine my like terms on the top to get 3 groups of root y over root 3y. And then now we're going to So in math, we don't like having radicals on the bottom. Radicals are like square roots or cube roots, all of that stuff, like all different types of roots. So in order to get rid of that, we have to multiply by root 3y over root 3y. And then that's going to get rid of the square root on the bottom, so we don't have to deal with it anymore. So then this is just going to be 3y on the bottom. And then we have 3 times, and then on the inside, we're just going to have 3y squared. So then you can obviously take out this y. So then it's 3y root 3 over 3y. So you can cancel those out, and you're just left with root 3. Someone said, can you slow down so I can copy? This all gets posted to YouTube later. So don't worry if you missed something or you came in late, like it gets uploaded on my YouTube channel, which is the same name as this, AG Tutoring. So you don't need to worry about copying stuff down. Let's keep going. So number 21, we have which of the following, so we're doing equivalent expressions basically. And also on YouTube, if you're watching this on YouTube, I say this at the beginning of my SAT playlist, but I know I tend to talk fast. Some people like it, some people don't. So one of the reasons I upload it to YouTube is because you can slow down or speed up the audio and like the video also based off your preference. So you can do that. Someone's asking, what would you say is the best way to study as a sophomore in geometry? Any math that you're studying for, the best way is going to be doing practice problem after practice problem and doing corrections. One of the biggest mistakes people make with math is like they get the problem wrong, they look at the answer key and they're like, oh, I can see how they got there. And then they think that they know how to recreate that and do it. And they don't actually like do the problem out and do the actual corrections. Don't do that. Basically, attempt to do the corrections on your own when you get something wrong and then verify that you did it the right way with the key. That's the best way. Are logs on the SAT or LN equations? No, that's ACT. So let's go to number 21. Which of the following expressions is equivalent to this? So again, we don't like those radicals on the bottom, but we can simplify root 16 because we know that that's a perfect square. And then you'll see we don't have anything that looks exactly like this yet. That's because we have to simplify the radical on top as well. So 12 is the same thing as 4 times 3. So I can take out a 2 for that 4 because the square root of 4 is 2. Keep the 3, put the 4 on the bottom, and then I could say, okay, I'm going to now divide by the greatest common factor. So that would be 2. So I'm dividing by 2 here to get 2. Divide by 2, get rid of that, and just leave the root 3. So it's root 3 over 2, D. Whoops. Okay, let's go to number 22. So we want to find the solution. So we're solving for x basically. So let's start by simplifying what we can. So we know that, I'm going to just copy down this part right there. And we know that we can figure out what the cube root of negative 64 is, and that's going to be negative 4. Let me just check. Yeah, that's negative 4. I'm not going crazy. So plus negative 4, which is the same thing as just minus 4. So that's what I'm going to do. And then I know that the square root of 49 is just going to be 7, because 7 times 7 gives you 49. So now I'm going to add 4 to each side. So then I'm going to get that the fourth root of x is equal to 11. And then now you want to get x by itself. So in order to do that, you have to get rid of this fourth root. The way we do that is by doing the opposite operation, which is raising things to the fourth power. So if I raise both sides to the fourth power, it gets rid of that for me, and I'm left with just x, and then I just have to figure out what 11 to the fourth is, which is just going to be, obviously, like, the only one that's big enough is going to be a. So I don't even have to, like, actually do the calculations or anything. So then let's, someone said, it's okay, you should see me, wouldn't it be imaginary? No, you're thinking of square root. This is a cube root. So like -4 times negative, that's supposed to be -4 times -4 gives you -64. So like you're thinking about if you had like the square root of -64, that's when you take out the I for the negative. So let's go to 23. Which expression is equivalent to this? So remember, you cannot use power to a power rule on something like this where there's a plus or minus in there. You have to FOIL. So this is going to be 2 plus the square root of x times 2 plus the square root of x is what that means. That we have two factors of that, or that times itself, however you want to think about it. So I'm going to now FOIL, which is an acronym. FOIL is an acronym that stands for what I'm multiplying together. So F stands for I multiply the first things together, so 2 times 2, which is 4. And then O stands for I multiply the outer things together, so 2 times root x, which is just going to be 2 root x. I stands for I multiply the inner terms together, so root x times 2, so plus 2 root x. And then L stands for I multiply the last things together, so root x times root x, which is just going to be x. Now I'm going to combine my like terms right over here. So I'm going to have 4 plus 4 root x plus x. And then that's going to be D.